picture of one of the enclosures. We have 4 of these in our HPSS system, and you can kind of see the tape cartridges there on the side, and in the center are the tape drives, and this is the exact same model we have. And for the outline, the first thing I'm going to cover is what is HPSS, using HPSS, and of course, how to put things onto the tape drives and on the tapes, how to get things back, a little thing into some side topics on HTAR, groups and accounts, where to go for help, and then we'll cover questions. Since this is being recorded, I would like to ask everyone to kind of hold their questions off to the end. In fact, for you that are online, I won't be able to see your questions until I exit full screen to the left, so you please be patient and wait to the end for me to get to your questions. So to begin, what is HPSS? Well, HPSS stands for High Performance Storage System. It's a little bit of a misnomer, sort of like discount grocery or anything else. High performance is not really all that high performance compared to, for instance, spinning disk or memory or anything else. It may be high performance compared to other tape systems. But anyway, that's the title that SimSolvent chose for it, so it's High Performance Storage System. Our particular system is a storage stack SL8500. It has 46 tape drives with 9,000 plus cartridges, or room for 9,000 plus cartridges. And we have roughly 320 petabytes of storage. Now, it's fairly slow as far as moving data from the tape through the network to the file system. That is around 100 megabytes per second. To give you some other comparison, on Clay, which is your usual disk drives, you get about 100 gigabytes per second. You're looking at orders of magnitude slower performance there. The other problem is actually, as I'll talk about later, is actually getting the tape to the tape drive, which can take what would seem to be an inordinate amount of time sometimes. Another thing to keep in mind is each tape, most of the ones we have now, I believe, are 8 terabytes in size. There are a few left that are 4. So, due to the software system, you can't actually write the file across tapes. So, any file you write to HPSS needs to be smaller than that. So, I wasn't actually going to show this video. It is a very boring and long video, but it does get the point across of what I mean about it takes a long time to get the tape to the tape drive. And so for those of you, when we release the slide later, you want to go back and watch this, the URL is up there at the top. And what you'll see is that the little arm comes around, seems to just take its time, it gets the tape drive, takes the tape, goes to the tape drive, sits there for a few seconds, then goes back. So gets another tape. And the whole point of watching this is just to get you to realize that this is a really slow process compared to, say, for instance, your flash drives where it's literally milliseconds to microseconds to access data. Here we're talking full minutes sometimes to get the data. And if there's a big rush, like you have 100 or more people trying to get data at the same time, you could spend 30 minutes waiting for your request to go to the arm, to go get the tape, to go put it in the tape drive. So, be advised. So some caveats on tape that most people don't realize. I'm going to tell you workflow as we would like to see it, and one of the reasons why, unlike disk, when you delete data on tape, it requires a lot of work to go back and restore the performance of the system and to make use of the space you just deleted. So we literally have to go take the tape where you deleted the data, take all the data off there, then repack it before that space can be reclaimed. You, of course, get instant credit for having deleted the data, but in the long run, we have to use more of our tape, and eventually, the way things are going, we may actually run out of tape at some point. So we ask people to please watch putting data onto the tape drive that you might delete. Tape can be overwhelmingly slow to access, and hopefully that's one lesson you will get from this. It's not uncommon to see access times in hours or even 30 or 40 minutes. Average time, assuming the tape is nearby and there's not much staying, you could probably get your data within a few minutes. Also, the tape is larger than our disk drives, but it's not unlimited in size. As I said before, you want to keep everything under 4 terabytes at the very largest. So our suggested workflow that we are suggesting now is that you do, say, a PBS job or some other job on the cluster. You write your data to our spinning disk systems, Blade Scratch or Blade P or even your home directory will fit. And from there, you filter out unwanted data, you compress, you do whatever you need to do to get this down to the bare minimum of data that you need. And that's what you would want to write out to the tape drive. We don't ask it. In the past, people have been treating the tape drive as sort of a scratch drive. So it's kind of permanent to get around the purging thing, but that is catching up with us, and we ask that people don't do that. And I guess a good rule of thumb is keeping the idea of quotas. Do not write anything to tape that you are pretty sure you're going to delete later. Try to do something else, pre-process that data, whatever you need to do to keep from doing that. So examples of really bad workflows that we've seen that people are even doing now. The first one is you write out hundreds of thousands of small files of tape, then read them back. As I mentioned before, it takes a long time to access a file. So if you can keep everything in one file and just access that file, you pay that penalty once. If you have hundreds or thousands of small files, you're looking at, even if you're getting 5 minutes per access, 5 minutes times 1,000 is 5,000 minutes, and that's a long time. This is really not a good workflow for you or for us. It cuts back on our performance, plus I'm not sure you would want to sit and watch this go by. The other is write everything to tape as you're doing your processing. Don't do any process post-processing, and then try to read it all back in and do post-processing then. That is not going to work in the new order we have right now. For one, you're going to run out of your allocation really quick. And two, as I said before, it will really slow you down. You're much better trying to post-process while the data is on Blade Scratch. And then, use tape purely just to store the results that you care about. Probably even worse is doing this multiple times. So you write data to tape, bring it back in, write it back to tape, bring it back in. Like I said, this is even worse. In short, our tape is for parking data for long-term storage. So, for example, a good use, many of you probably are aware that when you publish a paper, your data has to be around for, I think, 5 years, physical journal, for access. This would be a good place to put it for that reason. So, if for some reason you need to get to the data later, or there's a disaster, the file system crashes, and you need to get to the meaningful data, this would be where it should be. Finally, file size guidelines. These are the files, the size of the files you should write to tape. We wouldn't actually recommend writing anything smaller than 10 megabytes, just because it costs so much to access the file. At the same time, you don't want to probably want to keep your data under 1 terabyte. The reason I say that, if you remember I said the time to read data back is in hundreds of megabytes per second. You can literally spend an hour, even after accessing a file, to read a 1 terabyte file into the file back to the flash disk system. So you really want to keep your file less than 1 terabyte if possible. Now, okay, you might say, well, I do have hundreds of thousands of files. These are needed. I post-process them. What do I do? Well, one thing we could do is I will talk about the HTAR command later. In some cases, you can even tar or gzip them to a smaller file on the disk, and then write that gzip file to tape using the put command, which I'll talk about later. And, of course, the opposite extreme is, what do I do if I have files larger than this? Well, assuming it's 1 to 5 terabytes, you might be able to get by with it, but you'll have to really wait a while to write it or read it back. If that's the price you have to pay, and you're willing to pay that, I suppose that's what you'll have to do. You could try to compress it. try many things. Generally, though, you would probably either want to break the file up into something smaller chunks if possible, or do something else. Now, suppose I have 4 or 5 files or more on tape. I want to access them at once and bring them in sort of a logical order. You will probably want to do that in tape order, which I will show you how to do later. So, next question is, okay, I know what file sizes I need, I know a little bit about this tape system, what are our routes to it? And this is what's changed recently. So, in the past, we had Yellowstone, we had Geyser, etc. Some things haven't changed. You still have the command line option. You can, from Cheyenne or from the DAV nodes, what we call Geyser, we call DAV node. You could just type in your commands in the command line. Even kind of similar to this is the exact HPSS script, which you type this into the command line. It looks like a command line type thing. It even takes your terminal and holds the job until it finishes. What it actually does is take your commands, creates a batch job, sends it off to run on one of our faster data access nodes, and then returns back. First two have a problem, but oftentimes it takes a long time, so your terminal is basically frozen or not usable during the time these commands are being processed. In some cases, if there's an error, it will actually crash the terminal and we've lost that session, blah, blah, blah. So what we actually suggest for most people, and probably is best for most people, is to create a batch job using Slurm. You'll put a directive in to help use the HPSS partition, and submit this to Slurm, which will actually run not on the DAV nodes as you might think, but actually runs on our data access nodes. This is good for you, good for us. It's good for you because it's easier for you. It doesn't take up a terminal. It actually doesn't cost you anything. It's free, just like the old HPSS key was from Yellowstone. And it allows us to better process these jobs and makes HPSS run a lot smoother. So here's a little sample batch file. I'm not sure how much I should go into it for right now, but as you can see, we have for the -P up here for HPSS partition. So it's -P about the, I guess that's about the incline down. The first line of the script after all the SBatch directives, you should source the HPSS init file and bring in the right environment so it knows where to find HPSS and all the HPSS commands. And this is very important, and I would suggest anyone who is submitting either to PBS, Slurm, etc., use this. You want to set TIPDIR. So the TIPDIR is pointing to something in your blade scratch directory. The reason that is a lot of our software, even the Intel compiler, HTAR, HSI, etc., uses TIP files, and it puts them in TIP wherever TIPDIR points. For most systems, if you don't set this, it's using your local TIP or whatever that's, which is very, very small. You then overwrite that, you crash everything, the whole node goes down. Generally not fun for you or for us. So this is what we suggest, even if you don't want to use HPSS, you want to do something else, please try to keep that in mind. That's a good tip for all users. And finally, the last few lines of the script should be what your HSI commands are. We just have one line here, but this could be up to 20, 30 lines, whatever you want to put in there. And to introduce you to the HSI commands, I won't go into all of them. One thing you will see is they look a lot like the same commands you would have for the disk file system, which is the whole point of HSI, is to try to make the commands for using the tape drive look a lot like a disk drive, which is good and bad. It's easier to use, but oftentimes people get fooled. They're not the same. For instance, you can change directories within the tape drives. You can we'll talk about get and cget later. You can copy from one file from within HPSS from one tape to another, which I really wouldn't recommend, but you can do it. You can list what's in a directory. We have the put commands, move, make directories, and remove directories. Probably remove directory and remove are probably the two commands that will be useful if you're over allocation. So just keep that in mind. And then, so the commands that we really would care about, so HSI is like several software systems, whether the MPI or whatever. There's a lot of commands, there's a lot of advanced things, but in truth, you really only need 6 to 8 different commands to get most of 99% of what you want to do accomplished. The first of these is put. So there are two versions of put. There's put and cput. Cput is basically a protected put. So if you try to put something onto the tape drive, and there's something there with the exact same name of what you're trying to put on there, it won't do it. It will fail and tell you that, guess what? I can't put it, there's something there. Which can be useful if you don't want to overwrite something. On the other hand, you can do put, which will basically just doesn't care what's there or whatnot. It just takes something and does what you tell it to do and puts it on there. You will probably want to use cput for most of the time, though there are cases, I guess, where you might want to put. And if you want to change the name of a file, as you can see, this third line down here is HSI cput file name : new file name. And there's something similar for get, and this is basically the syntax. It's a little bit different than what you might find on our disk file system, but that's how you do it. And if you want to put a whole directory, you can do that. There's a command for it, cput-r for the person. I really wouldn't suggest that from the standpoint that you're getting to the point where you're writing hundreds of files or dozens of files. It's much better to use this HTAR. And this is why the whole point of HTAR is this. It's take a whole bunch of files and create one file on the file system. And there's the command for that. The -c in HTAR means to create. This is verbose. This is another flag that you probably won't care about too much. And of course, the name of the tar file comes first, and then the directory which you wish to create the tar file comes second. And when you're doing put or cput, you run into some things you really need to be aware of. First, for the first time, we are actually enforcing quotas in the tape drives. Basically, we are running out of space, and this is one way of trying to reduce the amount of space people are using. So you need to pay attention to your quota, for one. If you try to do a put and cput and you're out of quota, if you're using HSI commands, you will get this cryptic error code, HPSS _ EDQUT for quota. If you see that, you know you've probably written past your quota. Using the HTAR command, it gives you a -88 error code, which is not all that clear what happened, but now that you know what it is, it will be. The other thing you need to be aware of, if you're over quota, when it runs on Sunday, you have a little thing that goes to SAM. Tell SAM, this is how much data he's written, and the SAM will then turn off your ability to write the system. If you're over quota, you will have to remove files, and then probably wait a while for this system to run again to go back and allow you to write again. So I think it runs every Sunday, so you might have to go several days without being able to access the tape system. If for some reason it's prohibitively harsh, or you really need to write, you have a really good reason, you might contact Civil Help and they'll take your request under advisement. How you delete files is shown here. It's basically similar to what you would have on this file system. You can say HSI remove file name, or HSI-R remove directory tape viewer, which is whatever directory name you have on tape. Or another means of doing this is you can actually go through the files you own, and assuming, this is a big lot of assumptions here. I have a parallel project that's very close in scope. I have the okay of the project manager of that project to store my files into that project. then I can go and change what project each file is being charged to, and in the process reduce the amount of allocation that the first project has out. That is a little bit iffy, but you can do it. The third thing I would actually ask all people to do, and this is for your benefit, is to always check when you do something, putting things in a file, onto the tape drive server. You want to use the ls command with -u to check the path and the sizes to make sure they match what you have on the disk drives. You can also do the find, which will print out this particular one. The -m*90 says print out all transactions that happened within the last 90 minutes. You can change that to 120 or 30 minutes or whatever, but this will allow you to verify that the transaction took place. Now, you put things onto the tape system now. Obviously, at some point, you might want to get them back for some reason or another. To get them from tape, of course, it's get. And like put and cput, you have cget and get, and they're kind of the same thing. If you do cget, it will keep you from clobbering a file you already have on the spinning disk system. If you do get, it will just clobber. There's also a means of getting a whole directory at once with the -r cget takeover. Once again, I would recommend that unless you have already written it in a directory and you need to get it. I would actually do with the HTAR, and here's the HTAR command. The -x means to expand my tar file onto the disk drive. The -m here means, it's kind of important, it modifies the access times and so forth for what's being written to your bit file, so it's not has the same access time as which you wrote it, which may be 3 or 4 months ago, so it doesn't purge immediately. So remember that one. For retrieving, like I said, many are big files, it can take a while. And as I mentioned earlier, if you're retrieving several files, you probably want to retrieve them in tape order. So this is how you would do it. There's this kind of cryptic command here. And it works on ls-pr, and you give it a directory. In this case, I chose my home directory to HPSS. And then you stick this, and you will probably need to find this either on our online documentation or from this presentation to remember it, but essentially uses an awk command to filter out what's being printed out. And if you're familiar with awk, you may realize that what this does is, okay, the first column that's printed out for each thing is that a file. The file directory is what it says. It is that print the 6th column and the 2nd column, which the 6th column is actually the tape number that file is on, and the 2nd one is the name of the file, and then sort them. So here's like a sample output you might see. And I put this in red because this is going to be useful on the next page. You notice these all have the same tape number. This one is not the same tape number. These are all the same tape. These are not. And why is that important? Well, as I said before, when it goes to grab the tape and it puts it in the tape drive, the last thing you want to do is to go grab a tape, put it in the tape drive, then have to go grab another tape, then go back and get the same tape again. As you can see, that would actually increase the time to get this, get your task done by a whole lot. So you want to just be able to grab everything that's on the tape at once, take that tape and be done with it, go grab the next tape. So once you've done that, you take the output that I showed you earlier, that was in red. You create something here, I call it list file, but you can call it anything you want. And I take out the tape number and put it in get. And then I can run this by doing just an HSI-in list file. This HSI-in basically says, there's this file here. I want you to use this as input for a new command that just runs it, whatever's in that file. And this is how you optimize the file retrieval by tape. So when doing get or cget, we do run into a lot of errors, and we have a lot of users report things to us. The worst error you can actually have, and I don't have it listed here, is that the tape is bad. Now that is very uncommon. It's happened twice the whole time I've been there. So, but it does happen. So anytime you start seeing errors, again, it's cget, and you think you've done everything right, I would highly recommend you contact them with help about that. The usual errors, though, are the first one is not having enough space to transfer. So you have a 1 terabyte file on tape. You're trying to put it in your scratch directory, and guess what? You only have 300 gigabytes of space in your scratch directory. Things aren't going to work out so well. So it crashes, and tells you, nope, can't do that. And you're wondering why. Well, first thing to check is, do I have enough space? The second thing, as I was mentioning earlier, is not setting a temp dir. HSI does use your temp dir space to do some intermediate file processing, which is getting stuff from the tape. And that can easily run out of space and break up and cause the transfer to fail. And the third one is, I think, I really wish HPSS did not have this, but it does, so we have to live with it. There's a limit to 4 to 5 maximum concurrent transfers. What makes this even worse is if you try to do 20 or 30, it will actually work 85% of the time. So you think, that's okay, I can do that. And the one time it doesn't work, you realize, well, yeah, okay, done. So be aware of this. You can try to cut back the number of concurrent transfers. And probably the last one we always run into is, as I mentioned before, people will start a command, it will take forever and ever to run, and they get impatient and think that it's failed or something's wrong. When in fact, it's just that the system's really busy at that time, and it took 30 minutes to even get the tape drive, there's a tape into the tape drive, and another hour to write the tape for what's on the tape of the disk, and blah, blah, blah. So if it's taking a while, it could be just that you're it's going to take a while. One thing to note too, if you've touched a file recently, it will disk cache. There's a small amount of disk on the tape drive. And you can actually access it much faster on the second or third go. So just something to be aware of. And finally getting to HTAR. HTAR is sort of the thing we invented for everybody to take hundreds or thousands of files and create one big file that you can put on the tape system and get back from the tape system immediately. I've covered a lot of these already on how to create a file using a directory. This is one I haven't covered is how to list. So if I have a HTAR file on the tape, I can dash the dash T, D, and dash F. That will list what's in that tape archive, which could be very useful if you forgot to do it. The other thing you might want to do, I don't think the actual TAR for Linux has it. If you want just a specific file out of it, there is a way to do that. You just tell the usual command for untarring the file plus the name of the file you want, and it will get just that file. And if you leave that file name off, of course, it will give you everything that's in the tar ball on your disk drive. Now, I think I've covered that, the tar ball itself needs to be less than 4 terabytes in size because it has to fit on the tape. And you may be lucky with one of the few 4 terabyte tapes you have. The other one is kind of strange, I think. All the files that go into the HTAR ball have to be less than 68 gigabytes in size. We like to sit around at lunch and talk about why 68 gigabytes, but no one has a real good answer. That's what it is. 68 gigabytes. It's not 64, it's not 128, it's not even power, it's not even prime. So, I don't know, 68 gigabytes. So if it's failing to create a tar ball and you're trying to put in, say, a 1 terabyte file, then that's probably the reason why. Now, when you're creating tar balls, one thing you should be aware of is this is for taking small files and making one big one out. If you've got big files, probably not worth your time to even make a tar ball. Just write them out to the disk tape drive. But you could gzip them or something if you want to compress them to save space, but yeah, don't make it external out of it. Now, as I mentioned earlier, if you're running out of well on allocation, you may want to change the project code on some of your files. That's one reason for doing this. Another might be that the project you're on is ending. You have a new project, you don't want to see your files. We do erase the files after a certain period of time, after the project is over, if they're being charged to. So you will need to move them to a valid project. So this is another reason for why you might want to do what I'm about to talk about. But this is essentially changing the account or project code. So if you just do from the HSI man line or from HSI new account, it will list what your current project code is, what it thinks your default project code is for HPSS. Now, if you want to change it to something else, you would say new account plus the new project code that you want to change it to. And if you see an error after that, it may be that you're not on that particular project as an HPSS user. There are cases where people are on everything but HPSS for a particular project, and at this point you need to contact us to change that. But that would be how you would change it there. If you want to do, say, some series of HSI commands with a new account besides your default one, you would just pass -A and then new account with your HPSS commands, like here I use cput, cget, or whatever. For HTAR, it's -H, ACT equals new project code. To write this new HTAR ball to the safe system using that project code. And of course, once they're already written to do individual files, you will just use the CHACT, change account, to the new account name and then the file name. And I think that works for directories as well. -R. Now, the next one, groups. We're going to cover it, but very seldomly you need to change a group. It's probably better just to change permissions on the files themselves, but this is one way you can do it where you change a group on the file. Now, someone that's in that particular group can read it or write it or whatever, and you don't have to mess with permissions. Kind of a corner case, but you might want to do it. So, first way, of course, is to look at new group, which without anything on it will give you just what your group is at the time. If you want to change what group you're in, it's new group name. Looks like the account thing. HSI-G group name plus your HSI commands will give you all those commands executed under that group name. So if you write a file that has none of that group. For individual files, CH group, CHTRP, which is change group name file. And unlike account, you can actually talk about groups in terms of a group ID rather than name. So you can use the group ID, which is like a number, to change that particular group for a file. So finally, help. So maybe I didn't cover something, or maybe later on you're doing something and you realize there's an error and you want to get help. You can send, the best option first would probably be to look at our online documentation, which is second here, to see what's going on there. If that's not clear and you think there's actually an error what's going on with the system, we always, you can send your question, and we really usually ask you to run your command with a -D4 is an option. What that does is produces extra debug output, copy that and send it to us along with your question. And of course that send will help with UCAR at redo. And many times we don't need that, but in the times we do, it saves you a step of having to go back and rerun it. And from there we'll be able to help you. And I think at this time